Okay, so this is what the trig hexagon is supposed to look like at the end, but I actually want to construct this. My students normally they'll write this on the very top corner of their paper every time that they have a quiz or a test. So it's also important to realize what they're thinking about when they're constructing it, as well as what trig identities it actually exploits. So to start off with, there's always a couple trig identities that I think are non-negotiable when it comes to not knowing them. One of them is that sine over cosine's tangent, and also that sine squared of theta plus cosine squared of theta is equal to 1. Okay, so in setting up the trig hexagon, I set up with sine and cosine, and they know that that is tangent over here on the left, and I'll get to why that is positioned there. And also this squared sum rule, they know that there's a 1 involved, so they put the 1 in here. Okay. In constructing the rest of this now, they know that 1 over tangent is cotangent, so I'm going to put it across here from the tangent across the 1. And then at the very bottom, a lot of times I'm actually personally confused which one goes where, but the interesting thing is that all the ones on the right side all begin with a C. So this is cosecant over here and secant. So you get a hexagon figure with a 1 in the middle. And then we make triangular shapes. Look at that. We have this one and this one. So it almost looks like a biohazard sign at this point. Okay. So one of the interesting things about this is going around the hexagon. One of the first rules I talk about is anything over its neighbor is its other neighbor. So I might say sine over cosine is sine's other neighbor, tangent. And that's exactly one of the two that I tell students that they have to know. But also I can say, secant over tangent is secant's other neighbor, cosecant. Or that cosine over sine is cotangent. So you can get all those identities just by going around it. So the rule is anything over its neighbor is its other neighbor. Another one is using the 1 in the middle with anything to the outer edge and going all the way back across. So 1 over cosine is secant, or 1 over sine is cosecant, or 1 over cotangent is tangent. And then for the last set, it's the squared sums rule. So the 3 triangular regions that you made, the top 2, the sum of their squares is equal to what's on the bottom squared. So sine squared plus cosine squared gives you 1 squared, or just 1. And then over here, tangent squared plus 1 squared, or tangent squared plus 1, gives you secant squared. And then cotangent squared plus 1 squared, or cotangent squared plus 1, is equal to cosecant squared. So the interesting thing is that just looking at it, it's not the same as actually building it, because my students always had to build it. But in building it, they generally sort of notice that it's easy to set up the sine, cosine, tangent, and also putting the 1 in the middle from this rule. Then when they get to the bottom, they just have to realize that all their C's are to the right of it.